Good day, grade 11 STEM students. Welcome to the HP classroom. In this video, you will be able to determine the equation of a circle in its standard form. As what you have learned in the previous activity about conic sections, a circle is a special type of conic section or a special type of ellipse formed when the plane is perpendicular to the axis. It is a set of all points in a plane that has fixed distance r, known as the radius, from a given point C called the center. To visualize, let us take a look at this figure. This is a circle graphed in a coordinate plane where C is the given point called the center of the circle with coordinates 3 and 1. The distance between the center of the circle and a certain point A with coordinates -2 and 1 is 5. Because, using the distance formula, we can say that point A to point C is equal to 3 minus -2 is equal to 3 plus 2 equals 5. Since the line is horizontal, we can verify it by counting the number of units away point A is from the center. So we can count 1, 2, 3, 4, and 5. So let's say that there's another point in the circle named B with coordinates 6 and 5. Using the distance formula, which is B to C is equal to the square root of the sum of the squares of x sub 2 minus x sub 1, y sub 2 minus y sub 1. So I have labeled it here. So this is our x sub 2, y sub 2, point B, and x sub 1, y sub 1, C. Let's substitute. So we have square root of 6 minus 3, put the squared, we have 5 minus 1 squared. Since 6 minus 3 is 3, when we squared it, it is equal to 9, plus 5 minus 1 is 4, when we squared it is 16. So we have square root of 25. So the distance from point B to point C is equal to 5. So with these two examples, we can say that every point in the circle has the same distance from the center of the circle to any point. So we can also say that point P, if we have any point P on the circle, their distance will also become 5. To derive the equation of a circle in its standard form, we can consider this figure with point C as the center of the circle with coordinates h and k, and any point P on the circle with coordinates x and y, where the distance is called the radius, represented by r. Now, we can derive the equation. Since we know that C, or the center, C, or the center, has coordinates h and k, P has coordinates x and y, and the radius is equal to r. Using the distance formula, we can say that h will become x sub 1, k will become y sub 1, x becomes x sub 2, and y becomes y sub 2. Substituting it to the given distance formula, we have let's look for the distance between P to C, which is we all know is equal to R. So by using the distance formula, we will substitute these 2 points. So point P to C is equal to, what is x sub 2? It's x minus y, x sub 1 h, put the square, plus y sub 2 is y minus k, put squared, is equal to r. By squaring both sides of the equation, we can eliminate the square root. So we now have x minus h plus the square of y minus k is equal to r squared. And there you have it. This is the distance equation, standard equation of a circle with center at h and k and radius r. However, if in this figure the center is located at the origin, we can say that our center is at 0, 0. The value of h is 0 and value of k is 0. And after substituting it to our standard equation, which is x minus 0 y minus 0 equals r squared, we now have x squared plus y squared equals r squared. So these are the standard equations of a circle according to their location on the graph. So the first standard equation of a circle is not located at the origin. The center is not located at the origin, and center is located at the origin. So you will need this cheat sheet about the conic sections in understanding its standard equations and key parts as we go along with the whole topic of conic sections. But now we will just focus on circle in these 2 standard equations.